This question is on the magnetic field caused by a solenoid, and we are to draw a magnetic field line both inside and outside the solenoid. So we have to use our right hand grip rule for solenoid, and our fingers will curl in the direction of the current of a solenoid. And if we do that, we notice that our thumb is pointing towards the left. Our right thumb is pointing towards the left, indicating that the north pole of the solenoid is here, the south pole is here, and the magnetic field lines is along the right thumb, which is moving towards the left. And therefore, within the solenoid, the magnetic field line is moving towards the left. It exits from here, indicating that this part is the north pole of the solenoid, and then it will swing back and enter from the south pole of the solenoid. And this will be the answer. And I put in a diagram of the magnetic field of a solenoid for reference, and notice that what we are drawing here is actually this outermost magnetic field line. Now in the next part, if we change the direction of the current, what is the effect on the strength and direction of the magnetic field? When we change the direction of the current, the magnitude remains the same, and therefore the strength of the magnetic field remains the same. However, the direction of the magnetic field will be different. You can just use right hand grip rule for a solenoid to verify. In part 2, how do we represent on the magnetic field diagram that the strength of the magnetic field has increased? So we will draw field lines of higher density. Which means within the same space, we will draw more field lines, and the field lines will be closer together. In part C, we see a vertical wire KL with a current that is going from K to L downwards, and we are to determine the direction of force and how do we arrive at this direction of force. So over here is about Fleming's left hand rule. This is the direction of the force, and this is the orientation of your left hand when you apply Fleming's left hand rule. The direction of current is going downwards to the bottom of the page or the slide, which is indicated by your middle finger. The index finger shows you the direction of the magnetic field, which is going from right to left, as what we have determined from the earlier part of this question. And therefore your thumb would show that the force is going and pushing the wire towards this direction, towards the back of the card. And in words, this is how we describe the use of Fleming's left hand rule.